Okay, good morning, everybody, and welcome to our pre-calculus class. Today, what we're going to do is we're actually going to do the arc length lesson. I know it says here lesson 4, but lesson 5, it's supposed to be lesson 4. Okay, so this is going to be a little bit shorter and less intense than the previous lesson. So let's just get started. The formula S is equals to theta R, where S is the arc length, and theta is the central angle in radians, and R is a radius, applies to any circle. So S is equals to theta times R. Okay, so the S talks about the arc length. So if this is a circle, how big is this arc right here? Now this is not a line because it's kind of curvy. So what we need to do is, how do we measure this part there? That's the S part. Equal to theta. Theta is the central angle. Central angle is the angle that's coming from the center. So if this is the center point, then you have two lines going this way, which are R, by the way. They're both radius. In between the two rays here, that's the central angle. And R is the radius of the circle. So S is equal to theta times R. And the theta used in here is in radian measure. So the theta here is in radian measure, not degrees. So now I'm going to just talk about this very quickly, and then we'll move on to the rest of the lesson. In the past, you've probably learned the circumference. So when we look at the word circumference, it's the distance all the way around the circle. So circumference is equals to is the perimeter or the distance around the circle. And if you actually look at that one, and if you look at the formula for the circumference of a circle, it's actually 2 pi times r. So 2 pi times r. Let's see if we could figure that out. So 2 pi, that's the whole rotation. That's a whole circle. So that's the theta that they're talking about there. That's the theta. And then the r is the radius. So when we look at circumference is equals to 2 times pi times r, that's for the whole circle, and the theta is 2 pi. Now, in this particular case that we're talking about here is we're not talking about the whole perimeter or circumference of the circle. We're only just taking a portion of the circle. So in taking a look at example number 1, determine the length of the arc that subtends a central angle of pi over 4 in a circle with a radius of 4 centimeters. Now, if I'm going to just put this circle in a Cartesian plane, this is 0 and this is pi. Pi over 4, this is pi halves. So from here to here is pi. Halfway is pi half. Pi over 4 is over here. So we're looking for how big is this this part here. How big is this portion here, that arc? Okay, what other information do we have? So they're saying that this part here is pi over 4. So S is the arc length is equals to theta times r, radius. So let's figure that out. Theta is pi over 4 times the radius. Radius, they said, is 6. Now that's going to be 6 times pi divided by 4. So 6 pi over 4. And of course, we can simplify that fraction, dividing both sides and both the numerator and denominator by a common factor of 2. So this is going to be 3 pi over 2. So 3 pi. Now, because we're talking about the length of this arc here, that's, if we take our measuring tape and then put it from one end to the other, that's an actual length. That's the length. Now, because the length, what unit are we talking about here? What unit are we going to apply in here? If the radius is in centimeters, then that means that length there is also in centimeters. We can leave it as just 3 pi halves centimeters. Okay, or we can round it off to a decimal. It doesn't really matter. Okay, so let's take a look at example number 2. Determine the arc length of a circle with a central angle of 2.3 radians. Okay, 2.3 radians. Approximately, where is 2.3 radians? Okay, let's see here. So if this is 0 radians, and if you go all the way here, this is going to be pi radians, which is approximately 3.14. This one here is pi halves, which is 1.07. Okay, so where is 2.3? So 2.3 would be somewhere in the quadrant 2. Okay, so we're rotating 2.3 radians. So this is going to be 2.3 radians. So our theta is equal to 2.3 radians. It didn't ask us to really draw it out, but just it's nice to have a visual of what that looks like. And then what else did they give us? 2.3 radians and diameter of 8 feet. Now, diameter is from one end to the other. So that means we have to figure out the radius. Radius is diameter divided by 2. So it's 8 divided by 2, which is 4 feet. Okay. So now let's figure out the arc length. The arc length would be from here all the way there. This is the angle that's being subtended by this arc. Okay. This is the angle, theta, and then this is the arc. So S is equals to theta times r. So theta is the angle, so 2.3, times radius. Radius is 4. So 2.3 times 4 is going to give us 9.2. And now because this is the length, an arc length, it's not a straight one, but it's like an arc, but we can still measure that. It's 9.2 feet. There's a unit there, 9.2 feet. Okay, so that one's not so bad. Take a look at example number 3. Example number 3, a circle. A circle has a radius of 7.6. What is the measure of the central angle for the arc length to be 2.4 centimeter? So in this one is a backwards question. We call it backwards question because we have to solve something in here. We'll see what that looks like. So S is the size of the arc length is equals to theta times r, radius. So what other information do we have? They're giving us the radius, and they're giving us the arc length. So we're looking for theta. So arc length is 2.4 equals to theta times r. R is 7.6. Okay, so solve for theta, divide both sides by 7.6. 7.6 cancels. So theta is equals to 2.4 divided by 7.6 is approximately 0.32 radians. And 2.4 is the arc length divided by 7.6. Yeah, 2.2 radians. Okay, so that's that. That one's not bad. Let's go on to the next example. Determine the arc length of an angle. Determine the length of the arc that subtends a central angle of 25 degrees in a circle with a radius of 14 centimeters. Now, we said that S is equals to theta r works if the theta is in radian measure. So the very first thing we have to do is to change the angle of 25 degrees to a radian measure. So I'm just going to write that down. Change degree to radian first. Okay, so we can change it or we can figure out the equivalent. So what's that mean? We talked about changing the degree to radian in the previous lesson. So I'm just going to do this one here. 25 degrees. I'm just going to use here the unit analysis. So we know that pi radians is equals to 180 degrees. Okay. So what we need to do is, using the unit analysis, we need to analyze our units in here. This is degrees. So we want to cancel the degrees. So I'm going to put 180 in the denominator, and then the pi radians in the numerator. Okay, so this is kind of like a little bit of a review of what we've done. So 25 degrees times pi divided by 180. We certainly we can change that. We can go 25 pi over 180. Okay, so what number can we divide it by to get that? Okay, so we could divide both numerator and denominator by 5. So that becomes going to be 5 pi by 180 divided by 5 is 36. So this is what we're going to be using over there. So this is what we're going to be using for theta right there. So let's do that. S is equals to theta is 5 pi over 36 times the radius. Radius is 14. And in this particular case, we can just reduce. So So 14 and 36. So that's going to be, it's going to be 7. And this is going to give us 18. So that's 5 times 7. That's 35. So 35 pi over 18. So that's the length, the length of the arc. And what unit would this be? Okay, what unit would this be? Because this is an arc length, the length are going to be measured in centimeters. Okay, so this is the exact value. We can leave it like that, or we can write it in a decimal, but we don't have to. We can just leave it like that. Okay, so example number 5. A central angle of 5 pi by 8 creates an arc length of 15 meters. What is the radius of a circle? So a central angle of 5 pi by 8 creates an arc length of 15 centimeters. What is the radius? So S is equals to theta r. We're given the central angle, theta. We're given the arc length, which is the S. We're looking for the r. So r is equals to S divided by theta. Okay. So S is 15 divided by 5 pi by 8. Now we're creating here a complex fraction. So how do we divide 15 by 5 pi by 8? So this is the same thing as r. It's 15 times the reciprocal. So dividing a fraction is the same thing as multiplying the reciprocal. So 8 over 5 pi. So r is equals to, okay, so I can cancel the 15 and the 5. They have a common factor of 5. So this is going to be 3. It's going to be 1. So that's going to be 24 over pi. And in this particular case, because we're talking about radiuses here, radius has a length. And the length that is measured in also in meters. So we're not going to forget the unit for this one. Meters. Okay. Let's take a look at example number 6. How far does a bicycle wheel travel after 100 rotations if the wheel is 34 centimeter in diameter? Oh, that's really interesting because here this is the wheel. The diameter of the wheel. Okay, you can think of it. You can do the diameter vertically up, or you can do the diameter horizontally. Or it doesn't matter as long as it's from one end to the other. This is the diameter is 34 centimeters. 34 centimeters. And this thing is going to rotate 100 rotations. 100 rotations. So, you know that one rotation, that's one complete one, is going to be 2 pi radians. So we know that one rotation is going to give us a 2 pi radians angle. So it rotated 2 pi. Now, if we have rotated 100 times, so what's the angle there? So it's going to rotate 100 times. So it's going to rotate 100 times 2 pi. So therefore, theta is equals to 100 times 2 pi, which is 200 pi. Okay, so that means rotating it that 200 pi times. 200 times pi angle. So now, how much has it traveled? Okay. So S is equals to theta times R. So S, we don't know how far it will travel. Okay. So we know that theta is equals to 200 times pi, and then radius, we don't have the radius in here. We have the diameter 3.4. So radius, just write it down here, is going to be 17. Radius is from center to the end. So 17. And we just have to multiply them together, and that's going to give us S is equals to 3,400 times pi, 3,400 times pi. Okay, now we're not quite done because we're talking about the distance traveled. So the distance is 3,400 pi centimeters. Okay, that one's pretty easy, pretty good. It's just that one little piece in here that we had to do to find the angle. Okay, let's go to the last bit. A pendulum clock. Okay, we don't see a pendulum clock anymore, but basically a pendulum clock is like a clock that has like an arm that swings back and forth. Okay, it's called grandfather clock. So this is going to be swinging this way, swinging back and forth. So a pendulum of a clock is 42 centimeter long. So this is going to be 42 centimeter long. This is also 42 centimeter long because it swings back and forth, back and forth. If it swings through an angle of 32 degrees, so they're telling us the angle is 32 degrees here. Determine the total distance traveled in one complete swing. One complete swing. So if it swings this way, that's one swing that way. So and it says here to the nearest tenth. So S is equals to pi times R. So this is what we're trying to figure out. Okay, one complete swing, run this way. So S is equals to theta. Now, again, 32 degrees, we have to do a little bit of changing something there. So we know 32 degrees, okay, times 180 degrees in the denominator, pi radians in the numerator. Okay, so we're going to cancel the degree, and then we're left with radian. So 32 pi over 180. And of course, we can divide that. Okay, so we can divide both by, reduce by dividing by 4/4. Okay, we're going to get 8 pi over 45. So that's just reducing that. So putting that over there, and the pi, 8 pi over 45 into theta. So 8 pi over 45 times the radius. So the radius is this one over here, 42 centimeters. So let's multiply those together. So 8 times 42 is going to be 336 pi over 45. Okay, we could, it says here to the nearest tenth, so we're going to calculate that to the nearest tenth. So 336 times pi divided by 45, and it's approximately 23.5 centimeters. Okay. So it just swings this way, 23.5 centimeters. Okay, this is really going really fast. We're on a final example in here. Will give us a lot of time to do our practice questions for sure. So example 8, a center pivot irrigation system traces out a circular path. So it's an irrigation system. It basically shoots out like water to the land. So it pivots, the irrigation system traces out a circular path as it irrigates the farm fields. One system has an arm 36 meter long, and the speed of the end of the arm is 3 meters per minute. In radians, through which angle will the arm have rotated after 30 minutes? 30 minutes. Okay, so this is like a question here. So, okay, so I'm just going to draw it out and see if we can make sense out of these questions here. So this is the irrigation system. Okay, so it's right there. That's where the water is coming from. And it pivots. It means it turns. It's around there, and it traces a circular path. So it's circular path. It shoots water there that way. And it says here, one system has 36 meter long. Yeah, so there's irrigation here. 36 meter long line in here, and it traces the path there. Okay, that's pretty big. And it says here the speed of the end of the arm, so speed here, it rotates, and it doesn't matter where it rotates. It says here 3 meters per minute. So it's gonna rotate like this. We'll go this way. 3 meters per minute, 1 minute. Okay. So the question is, in radians, which angle will the arm have rotated after 30 minutes? Okay. So in 1 minute, it turns 3 meters, right? So we can say 3 meters per 1 minute. Well, how many meters would it turn? How many meters would it turn in 30 minutes? So if we're going to cross multiply that, that's going to give us x equals to 3 times 30, which is 90 meters. So in every minute, it will turn 3 meters. So 3 meters, 3 meters, 3 meters. So in 30 minutes, it's going to have to turn 90 meters. Okay, so it would have turned, in 30 minutes, it would have turned 90 meters. So let's just right go here. 90 meters it would have turned. So the 90 meters actually is the S value. This is the S value. Okay, the length of the arc. Okay, and then what else do we know? So we know what the radius is. We know that. So we're looking for what is the angle? What is the theta? Okay, so S is equals to theta times R. We know what the S is, and we know what the R is. We just look for theta. So theta is equals to S divided by r. So S is 90 meters. Radius is 36 meters. Okay. So that's going to give us 90 divided by 36. It's going to give us a 2.5 radians. That's how much it has turned, 2.5 radians this way. Okay, so example number 8 and example number 7 are just application questions in here. In terms of practice questions, you have these questions that are prescribed on the book. If you have any questions in any of these, please let me know. I also have, in terms of review, okay, in terms of review questions, you have quite a bit of review questions from the book so that we can prepare for a test. Review questions are from page 505 to 509, questions 1 through 12, and page 560 to 562, questions 1 through 8. So these ones are quite a bit of a review questions for you to try. Please try them. Those ones would be something really, really beneficial for you for your tests coming up. So reminder that the test, chapter 6 test, is on Tuesday next week, May 19. Okay. May 18th is actually a holiday. It's a Victoria Day holiday. So there is no school on Monday next week. That's why we're writing our test on the 19th. Okay. So if you have any questions on the topics from the book, please let me know. I've posted some answers online on our blog. And if there's any other ones that you want me to go over, I'll go over it with you, or I'll post some stuff on the blog too. Okay. There you have it. We've finished our chapter 6. The rest of the day, we can just work on some of our questions prescribed in our book. And if you are very, very proactive, you can actually get started with the review questions from the book. Okay, so there you go. I'll leave that with you. Of course, you can send me an email and then I'll try to respond to you as soon as I can. And yeah, have a great day of learning and working. Keep at it. And yeah, if you have any questions, let me know. Okay, have a great day, everybody. And thank you for watching. Okay, bye for now.